Hi. So maybe you as a beginning programmer are looking for a better job and you have realized that you need to be solving computer problems, but not the real problems you will be solving day to day, like the toy problems, and you need to demonstrate your knowledge by solving one of them. So some people find it hard, and understandably so, because the first time such problem was solved by somebody, it was probably a small research project, and now it's expected that we can repeat that. And I am going to present some algorithm, some common way of looking at any of such problem and approaching it, which maximizes your chance of success in an interview. So let's take a look. Right, so to understand why this algorithm is good, we want to think what has been looked at in an interview. Why are they asking us that? What are we being tested for? And the first thing which we are being tested for is how well we can understand some programming tasks. Because even if you don't know the solution, understanding the task means you can ask relevant questions. You can get forward by either asking colleagues proper questions or just Googling. So this is really the first step. And what it boils down to in a programming task, it boils down to understanding your data flow, so what comes in and what comes out of your piece of code, either it's a small function or a class, because any useful software either produces an output or produces some side effects, but usually on the interviews we will not be looking at side effects like changing some config of your operating system or anything like that would not be an interview task. So after understanding the data flow, you need to understand the assumptions about your inputs and outputs. So why a particular output must be produced? What specifics can you tell about your inputs? What is the type of your input? What is possible value range of this input type? Will it come, for example, for an array in a sorted order or not? So any of those details comes as assumptions. And if you think you're done, if you think you understand the data flow and you understand the assumptions, you should look at an example and verify that. So on some programming platforms, you will see examples being provided to you to better explain a task. But if it's not, then you should come up with an example yourself. So just pick any random inputs which can so far adhere to the assumptions you have identified, and ask your interviewer like, okay, assuming I want to find sum of, I don't know, let's say I want to find sum of k biggest elements in an array, right? So then you will say, okay, my input is a list of integers. You can ask, is it sorted or not? You should look for that, but basically, if it is not told, then you can tell your assumptions ahead for your solution yourself. You can say, okay, I will assume it is not sorted because in general, a sorted array is, let's say, a special case, and some random array is not sorted. So for any reason, you can just state your assumptions yourself. And given this example with summing k biggest element, you would say, okay, so if you give me an array of 1, 2, and 3, and you say that the k is equal to 2, it means my biggest elements are 2 and 3, and you are expecting output of 5 from me, right? Right. Then you can test for a few more things. You can ask, okay, if it is nowhere clear stated, in terms of your examples, you can ask yourself for some things like, can there be a negative element in my array? Can there be 0? Can there be repetitions? Those all are good in the company I'm working for. I work for Amazon. And by the way, the opinions I share are just my own and not of my employer. We are being instructed on how to conduct the interviews, and actually we value when people ask questions because it shows they have some structured approach. They don't just jump to some conclusions without being clear about where these things come from. Because, sometimes under the stress, you can just think, oh, it must be this thing which I have seen before, and this can come as a hidden assumption. You don't even realize you have made it, but you immediately think about it, and in the mind of the interviewer, it's something else. So it's not the best thing to happen. So ask as many questions as you can. Aside from that, once you have understood that, what you could do first is the brute force solution. So what is a brute force solution? It's an inefficient solution which nonetheless produces correct outputs. So why would you go for inefficient solution first? Okay, you would go for it because it's easy. So this is your chance to score some easy points on the task. This is also useful in many settings because you can compare your efficient solution to an easy solution. This is just, again, a structured way forward. We're starting from brute force solution, which is inefficient. You can later tell, okay, these are the problems with this solution, which this is how we could improve it, and then you try to improve it. So if you fail, you already had something. You have shown you're able to analyze your code. You have shown you know what are the problems. And overall, it's like, if you will be solving multiple problems, maybe you will not be able to solve some of them perfectly. So it's an easy way to score some points. So I expect to make a next video where I demonstrate how to approach that. Okay. Just a few more words. When you are thinking about brute force solution, you're thinking about some way to enumerate all possible options. So, for example, for returning k biggest elements, sum of k biggest elements in an array, I could find all possible combinations of k elements, sum them, and return maximum of that. It's conceptually simple. Of course, it's inefficient. Exactly. This is our first chance to demonstrate that we understand the concepts of runtime and memory complexity, and it's a very good, clear case, because usually your solution to brute force will not be too elaborate. It will be some looping over a lot of elements, and you will just be able to demonstrate it. You know that. Okay. Third part is to attempt the efficient solution. Why I'm saying attempt? Because it's all up to your current knowledge and the difficulty of the problems, because some problems, they're just too difficult to be solved in a limited, in 1 hour and whatever time you will get, if you don't have the right background. So if you're getting some graph theory problems, or even if you're asked to efficiently sort an array and you have never read the theory of sorting arrays, people have spent their PhDs, like 3 years or whatever, inventing these sorting algorithms. What is the chance that you will come up with it in 1 hour? It's literally so improbable that you don't have to expect that. So I'm saying attempt. Nonetheless, there is again some structured approach to it. You have written your brute force solution. You have identified inefficiencies of it, right? So by saying that something inefficient means you already have some concept of some condition under which it occurs, and some better way to process that. Those are very generic things, and it's much better to look at an example, but those are the general ideas. And remember, always keep documenting it, because there might be just a small bug. Maybe you were very, very close to the solution, but you didn't get there. And by documenting it in the interview, by writing down your ideas, writing down your assumptions, writing down your code, people will later be able to argue that you were really close to it. You were not just, you didn't just give up and produce nothing. You were really close, and it was up to the chance, maybe you needed 5 more minutes and you didn't have it. So reasonable companies are interested in getting you if you are a decent programmer. So give them this opportunity, document your solution. Okay, with that, we are done with overviewing this algorithm, and in the next video we will look at how that works in practice.